Hi everyone and welcome to another video of vector mechanics. So today we're going to be looking at vector analysis for motion on a Cartesian plane. How does this work? Let's learn in today's video. Alright, vector analysis for motion in a Cartesian plane. So a Cartesian plane is a two-dimensional coordinate plane formed by the intersection of x and y axis. So I just want to put that across the way so that you can actually know what we mean. So we're going to consider a particle which has initial velocity u from a point A with position vector r bracket 0 and moves with a constant acceleration a if after a time t it passes through a point B. Then we have, alright, so representing it on a Cartesian plane, this is what we have. Alright, so from this diagram we can set r not or r0 is the initial position vector. S gives you the displacement from the initial position. RT represents the position vector at any time t, and then what we shall have it is this way. So to find RT, the position vector at any time t, we shall have initial position vector plus AB. So that's the same as the distance moving from A to B, the displacement from position A to position B, as you can see right there. So as you can see, this is what we'll have, but S is ut plus a half at squared. Alright, so this is the formula that is most important for you to memorize and have in mind as you prepare to work on different numbers in this section. So we shall also make use of three equations of linear motion and Newton's second law of motion, which is F is equal to ma, expressed in vector form. So all this depends on the question. So for example, remember the three equations of linear motion: v is equal to u plus at, s is equal to ut plus a half at squared, and v squared is equal to u squared plus 2as. So all these shall be crucial in this section. Alright, so let's look at a question. Question 1. The question says a particle initially passes through the point 3, -2 with velocity -4i plus 2j meters per second while accelerating uniformly, and in 4 seconds it covers a distance of 8√5 meters in the direction I plus 2j. Find 1. the acceleration, 2. position vector after the 4 seconds. So let's first list what has been given. So now we've been given the initial position vector as 3i minus 2j. As you can see, it has been given in terms of coordinates, but now we can say this represents x and this represents y. So this can actually be placed in vector form as 3i minus 2j. So now we know the initial position vector. So we can also say that we've been given the velocity, the initial velocity, which is -4i plus 2j meters per second. So we also know the time now that it covers, how much time it takes to cover a certain distance. Then we can also say the magnitude of the distance has been given as 8√5 meters. So what are we going to do? So the first step is we can actually see that this magnitude has been given in terms of a quantity. So now we want to first convert this into vector form. So the magnitude has to be converted into vector form since it's actually not a scalar, so it can actually be converted into vector form. Now time can't because it's a scalar quantity, so we're going to focus on converting this distance into vector form. So we shall have it this way. So s shall actually be equal to the magnitude of that distance times, now we're going to have the direction, so the direction is here, so we're going to have the unit vector of this direction, which is I plus 2j over root of 1 squared plus 2 squared. So you shall have it this way. So when I multiply, I can see that this √5 and this √5 cancels, and I'll be left with 8 times I plus 2j, which is 8i plus 16j meters. So that is the magnitude of the distance. So that is the distance put in vector form. So now that I know that distance in vector form, I can actually now work on finding acceleration. Now remember, from this formula, this is the second equation of motion. S is equal to ut plus a half at squared. I already know what the distance is. The distance is 8i plus 16j, and then I know what the initial velocity is. It's -4i plus 2j times 4 plus a half a. Now a is the unknown that we're looking for, times 4 squared, because the time taken is 4 seconds. Alright, so working this out, I'll have 4 times -4, which is -16i, 4 times 2, which is 8j, as you can see. Then this side I'm left with a half times 4 squared. Now 4 squared is 16, a half times that is 8. So 8 times a is 8a. So that's why I'm left with it this way. So next, I'm actually going to add these two vectors. So when I actually take this to this side and I add the two vectors, this 16i will become a positive. So 8i plus 16i is 24i. This 8j will become a negative. So I have 16j minus 8j, which is 8j. So 24i plus 8j shall actually be equal to 8a. So now I'll divide both sides by 8, and then I'll have a as 3i plus j meters per second squared, and that is the acceleration. So therefore the acceleration of the particle is 3i plus j meters per second squared. So in part 2, we're being told to find the position vector after the 4 seconds. So now we remember that the formula for position vector is, so we're going to find it from this. So from rt is equal to r0 plus s, I'm going to plug in the value. So I actually know the time taken is 4, and then I know that the initial position is 3i minus 2j, because that is already given. So now I'm going to add this to the distance. So remember, the distance is 8i plus 16j. So now 3i plus 8i is going to give me 11i, and then 16j minus 2j shall give me 14j. So this is what I have. So therefore the position vector of the particle after 4 seconds is 11i plus 14j, and that is the answer they wanted. So next question is a question from UNEB 1997, and this was question 3. So being told that a particle with position vector 10i plus 3j plus 5k moves with a constant speed of 6 meters per second in the direction I plus 2j plus 2k. Find its distance from the origin after 5 seconds. Alright, so how do we solve this? Let's first look at what has been given. So we've been given the initial position vector as 10i plus 3j plus 5k. Then we've been given the magnitude of the speed as 6 meters per second. And then the time taken is 5 seconds. So now, first of all, we're going to convert this speed here into vector form, because this quantity we need to convert it into vector form. So how are we going to do it? We're going to multiply that speed, which is the magnitude here. So to find that u in vector form, it's going to be this magnitude here times the direction vector, times the unit vector of the direction. So this is what we have right there. So we'll have 6 times that, of which I know root of 9 is 3, and this I'll be left with the 2 right here. So I have 2 times I plus 2j plus 2k, which is equal to that. So I have 2i plus 4j plus 4k meters per second. So now we've converted that initial speed into vector form. So now that we have that, we can now find the distance. Now, since speed is constant, now pay attention to those words. Since the speed is constant, it's saying we're doing this, the particle is moving with a constant speed. Now, when speed is constant, it means that acceleration is equal to 0 meters per second squared. So, from the second equation of motion, s is equal to ut plus a half at squared, this is what we'll have. We're going to have s being equal to, so s is the distance, it's going to be equal to u times t, of which we have u as 2i plus 4j plus 4k times time taken, which is 5, plus a half times 0, remember that acceleration is 0 when there is constant speed, times time, which is 5 squared. So as you can see, this 0 cancels out every side here, and then we're going to have 5 times 2i plus 4j plus 4k, which shall be equal to s being equal to 10i plus 20j plus 20k meters. So now, because we're being told to find the distance specifically from the origin, we're going to make use of the formula that were given at the very beginning. So remember that RT shall actually be equal to the initial position vector plus S. Now we're going to look for the value of R at the position where we have 5 seconds. So this is now what we're going to have right here. So we know that R as 0 is, so the initial position vector is 10i plus 3j plus 5k plus this value of S that we had actually found right there. So when we add this, we will have 20i plus 23j plus 25k. So now we know that distance from the origin is going to be that way. Alright, so to find its magnitude, this is what I'll have. So I'll have the square root of this, and then I'll have it as 20 squared plus 23 squared plus 25 squared then I'll have the square root of 1554, which shall give me 39.42 meters, and therefore the distance of the particle from the origin after 5 seconds is 39.42 meters, and that is what we are looking for. So the next question is a question from UNEB 2007, and this was question number 8. So being told that the initial velocity of a particle moving with constant acceleration is 3I minus 5j meters per second. After 2 seconds, the velocity of the particle is of magnitude 6 meters per second and parallel to I plus j. So find the acceleration of the particle. Alright, so first of all, we're going to convert that value of v into vector form. So now that velocity v is the velocity after a certain time has actually passed, so it's not the initial velocity. So that particle v is what we have to first convert. So we'll have 6 times. Now we're going to get the unit vector of this that it's parallel to. So this is going to act as the direction. So I have I plus j over root of 1 squared plus I 1 squared. So v shall actually be equal to this. Now remember that this shall give you root of 2, so you can separate it that way. So when I multiply the 6 inside, I'll have 6I over root of 2 plus 6j over root of 2 meters per second. So now I have v in vector form. So now I can see next that since u is known and v is known, and what I need is to find the acceleration, I can use the first equation of motion. So we know that v is equal to u plus at. So I'm going to plug in the value of v, and time is known, so time is 2, so I have 2a. So now this is what I have. So I'm going to collect like terms. So I'm actually going to take the vectors to the other side. Then when I subtract, so the I is subtracting themselves, I'm going to first open the brackets. So when I open the brackets, this is what I end up having. And then I can see that this is what I'll have. So now what happens is I can actually subtract these together, and this is what I end up having. And then next I can divide both sides by 2. So this is what I have, that I have outside into that. Alright, so when I multiply the I have inside, this 6 and the 2 give me 3 up here. Then the half times this will give me 3 over 2i. A half times this, I'll be left with the 3 here. A half times this, I'll have 5 over 2j, as you can see right there. So now the answer of acceleration shall be 3 over root of 2 minus 3 over 2i plus 3 over root of 2 plus 5 over 2i meters per second squared, and that is the answer. So the next question is a question from UNEB 1996, and this was question 2. So being told that a particle with a position 40, 10, 20 moves with a constant speed of 5 meters per second in the direction of the vector 4, 7, 4. Find its distance from the origin after 9 seconds. So as you can already see, this we're dealing with constant speed, and as I said, whenever I hear the word constant speed, it means that acceleration is 0. So let's solve this. So now we can already see that we know that the initial position vector is 40i plus 10j plus 20k, as it's given right there. Then you can also see that the initial velocity is 5 meters per second. And then you can set this happens, or the movement happens in a time of 9 seconds. Alright, so first of all, we're going to first convert this initial speed into vector form. And that means we're going to multiply it by the unit vector of the direction. So we're going to have u being equal to 5 times this. So we're going to have the unit vector of this, which shall be that, of which we shall have it this way. So we shall have 5 times that, which I'll be left with 5 over 9 into bracket 4i plus 7j plus 4k meters per second. So that is my initial speed in vector form. So now that I have that, I can find the distance. So now the first process is, remember that speed is constant, so that means acceleration is 0. So from s is equal to ut plus a half at squared, that means we have s being equal to 5 over 9 4i plus 7j plus 4k times 9 plus a half times 0 times 9 squared. So as you can already see, these will actually become 0. So next I'm left with 9 times whatever I have here. So as I can already see that this 9 and this 9 cancel, so I'll be left with 5 with these, multiplying them, and then I'll have it as s being equal to 20i plus 35j plus 20k meters. So now, since I'm looking for distance from origin, I'm going to make use of this formula, which is rt being equal to r0 plus s. Now remember the time is 5 seconds, so I'll have it as 40i plus 10j plus 20k plus the value of s that I've actually found. So this is what I'll have it as 60i plus 45j plus 40k. Alright, then next find its magnitude. This is what I'll have the square root of 60 squared plus 45 squared plus 40 squared, which shall be like the square root of 7,225, which the answer will be 85 meters. So therefore, the distance of the particle from the origin after 9 seconds is 85 meters, and that is the answer we're looking for. Alright, so next question, we're being told that a particle travels with a speed of 12 meters per second in the direction 2i plus j minus 2k, and 4 seconds later its speed is 18 meters per second in the direction 7i minus 4j plus 4k. So being told to calculate the average acceleration of the particle in the 4 seconds. So as you can already see, initial speed and then the value of v is also given. So that means we're going to first convert those speeds into vector form. So u has been given as 12, so we're going to multiply times the unit vector of the direction. So this is what I end up having. As you can see, root of 9 is 3. Now when I'm 12 times a third is going to give me 4, so I have 4 times 2i plus j minus 4k, which shall be 8i plus 4j minus 8k meters per second. So now I know the initial speed in vector form. How about the value of v? So v shall actually be equal to 18 times that, which shall give me, now we can say that root of 81 is 9, so this is what I have. Now 18 times 1 over 9 is going to give me 2, so I have 2 times that, which is 14i minus 8j plus 8k meters per second. So now I know what u and v are in vector form. So now that I know the value of u and v, and then my target is to find acceleration, I can make use of the first equation of motion, which is v is equal to u plus a t. Now this is what I have. So for the value of v, I've placed it there, the value of u is there, and now the time given is 4 seconds, so I have 4a. Now I can actually take the value of u to the other side. Now when I subtract, this is what I have. I'll be having 6i minus 12j plus 16k being equal to 4a. Now I'm going to divide both sides by 4, of which a shall actually be equal to a quarter, 6i minus 12j plus 16k meters per second squared, and that is the value of the acceleration. Question number 6. We're being told that a particle moves from A, which had the coordinates 2, 1, to B, which has coordinates 9, 25, along a line with a constant speed of 50 meters per second. So we're being told to find its velocity vector and time taken to move from A to B. So first of all, we need to find AB. Now AB shall actually be equal to OB minus OA from the knowledge of vectors. So now we know the coordinates at the vector at position B, which is 9, 25, and that as position A, which is 2, 1. So we're going to subtract them, and what we'll have is 7, 24. So now we know what the value of AB is. So next we have this constant speed right here. Now remember, when there's constant speed, it means that acceleration is 0. So we're going to convert this 50 meters per second into vector form. As you can already see, this AB is going to act as its direction. So we're going to have 50 times, now this is representing its direction vector. So we're going to get its unit vector. So its unit vector is 7i plus 24j over root of 7 squared plus 24 squared times this 50, and then we shall have the value of v in vector form. So I'll have it as 2 times 7i plus 24j, which is 14i plus 48j meters per second. So now I know the value of v in vector form. So next I can now find the distance, but before I do that, I remember that since speed is constant, acceleration is 0 meters per second squared. So now from the second equation of motion, we'll have s being equal to this. So I have 7i plus 24j being equal to 14i plus 48j times t plus a half times 0 times t squared. Alright, so this side cancels out because 0 times that is 0. So I'll be left with 7i plus 24j being equal to t into 14i plus 48j. So as I can already see from this side, I can actually factorize out a 2. So this is what I have. So once I factorize out a 2, I have 2t into 7i plus 24j j. So I want to make 2t the subject, so this is what I have. But 7i plus 24j over 7i plus 24j will give me 1. So I'll have 2t being equal to 1, of which t shall actually be equal to a half. So I have the time taken as being 0.5 seconds. And as we found earlier, its velocity vector is 14i plus 48j meters per second. And that is what they wanted. Alright, so the next question is a question from UNEB 2011, and this was question number 2. So being told that a particle of mass 2 kilograms moves under the action of 3 forces, F1, F2, and F3. At a time t, F1 is a quarter t minus 1i plus t minus 3j newtons. F2 is a half t plus 2i plus a half t minus 4j newtons, and F3 is a quarter t minus 4i plus 3 over 2t plus 1j newtons. So these are all two-dimensional. So being told to find the acceleration of the particle when t is 2 seconds. So first of all, as you can see, we've been given multiple forces. So first of all, we need to find the resultant force. So the resultant force F shall be F1 plus F2 plus F3, and then this is what we end up having. So when you add everything step by step, this is what you end up having. So I'll be left with t minus 3 at the top, and then at the bottom I'll be left with 3t minus 6. So now that I know the resultant force and I know that the mass is 2 kilograms, I'm going to find the acceleration from Newton's second law of motion. So from Newton's second law of motion, I know that F is ma, and then if I make a the subject, a shall actually be equal to F over m, of which it's the same as this. So it's the same as a half, because m is like 1, because we're dividing F over 2, it's the same as a half times this force right there. So when t is 2 seconds, because we're told the time taken, we're going to substitute in for the value of t, and then I'll have at the top 2 minus 3, and at the bottom I have 3 times 2 minus 6. So I'll have 2 minus 3 over 6 minus 6, which is negative 1 and 0. So this is the same as negative I plus 0k. So therefore, as you can see, since there is a coefficient of 0 where there is k, I can ignore the k side and I'll be left with only that of the I. So therefore, acceleration is negative a half I meters per second squared, and that is the answer. Alright, so in the next question, we're being told that the acceleration of a particle is negative 10j. So that means that the coefficients where there is I and where there is k are 0. So if the particle starts at 0, 80, with a velocity 15i, find the velocity at time t is equal to 5. Then in part 2, we're being told that given that at a time t, the particle is at x, 0, calculate the values of x and t. So first of all, the initial velocity is 15i meters per second. So it just simply means that the coefficients at the j and the k are 0. So this is what we'll have. And then acceleration is negative 10j meters per second squared, and then the initial position vector shall be 80j. And why is that? It's because where there is I, we'll have a 0, so 0i is basically 0, so I'll be left with 80j. So that's what we shall consider as our initial position vector. So first of all, we want to find the velocity at time t is equal to 5. So what are we going to do? We're going to use the first equation of motion, and it's because we know what the u value is, we know what acceleration is, and we know the time that we are given. So you can use that to find that velocity v. So we're going to have v being equal to 15i plus, into bracket, negative 10j times 5, of which we'll have it this way. So I'll have it as 15i minus 50j meters per second. So therefore, the velocity of the particle at time t is equal to 5 is 15i minus 50j meters per second, and that is the answer they wanted. So now for part 2, first of all, I'm going to first find the equation for the position vector at any time t. So I'm going to first find that general equation. So I'll have rt being equal to r naught or r0 plus s. So we know that at r0, the particle starts at 0, 80. So it's 0i plus 80j plus, we know the equation of s is ut plus a half at squared. And then remember that we can ignore the 0i, so we'll be left with 8j. And then where there is u, remember that the velocity at u, the initial velocity is 15i t plus a half a. Now remember that a is negative 10j, as you can see right there. So now, since we're just dealing with the general equation, we're going to leave this t as it is. And then lastly, this is what I'll have. So as you can see, this and this can be combined because they all have j. So I'm going to have 15it plus this 8j minus 8 minus 5t squared, then bracket j, as you can see right there. So this is more of a general equation for position vector at any time t. Now the reason we have this is because we're being told that given at another time, at a certain time capital T, the particle is at x0. Calculate the values of x and t. So now let's look at it from that time where we have capital T. So first of all, we know the position vector at that time capital T that we don't know. So RT shall actually be equal to xi plus 0j. Now those are the coordinates that were given. So we're given x, 0. Now, also we know that this can also be stated as r capital T being equal to, now we're going to be making use of that general equation that we've been given, but wherever we have small t, we're going to put capital T. So we're going to have r capital T being equal to 15i capital T plus bracket 8 minus 5 capital T squared j. Now as you can see, this and this can be equated. So this means that we'll have xi plus 0j being equal to 15it plus bracket 8 minus 5t squared j. So now let's compare the different two sides. So if we compare the sides where we have the I, this and this, we can see that we'll have xi being equal to 15it, of which if the i's cancel, I'll be left with x being equal to 15t, and that shall be equation 1. So now for the j's, I'm going to have 0j being equal to this 8 minus 5t squared j. Now the j's cancel and I'll be left with 0 being equal to 8 minus 5t squared. So now take this to the other side and I'll have 5t squared being equal to 80. Make t squared the subject and it will be 80 divided by 5, which is 16. Now we know the square root of 16 is 4. So capital T is 4 seconds. So now we know the value of capital T. Now substituting for capital T into equation 1 to find x, I'm going to have x being equal to 15 times 4, which is 60 meters. So now I know the value of x and I know the value of t. And these are the answers that they wanted. Alright, so next question, we're being told that a particle P leaves the origin and moves with constant velocity 2i plus 6j meters per second, while particle Q starts from the origin with initial velocity 4i minus 8j meters per second and moves with acceleration I plus j meters per second squared. Find part 1, the position vectors of P and Q after 2 seconds. Part 2, time at which the velocities of the two particles are perpendicular to each other. Part 3, time at which the point R with position vector 17i plus 25j lies on the line joining the positions of the particles P and Q. Alright, let's deal with this one at a time. Let's look at part 1. So we want to find the position vectors of P and Q after 2 seconds. Let's first look at particle P. So particle P, we're being told that its initial velocity UP is 2i plus 6j meters per second. Then we're going to have its acceleration P being equal to 0. Why? It's because we are moving at a constant velocity. And then, as you can see, if we want to find the position vector at any time t, so for P we'll have RPT being equal to RP0 plus SP, of which, since we're looking at a time of 2 seconds, in this question we've been looking at that position vectors after 2 seconds, this is what we'll have. So we'll have RP2 being equal to 0i plus 0j, and why is that? It's because it leaves the origin. So starting from the origin where the coordinates are 0, 0, plus, as you can see, we'll have SP is ut plus a half at squared. Now the value of u is this, so its initial velocity up is 2i plus 6j times 2, which is the time, plus a half times 0 times 2 squared, of which I'll eventually have 4i plus 12j. So that is the position vector of P after 2 seconds. Alright, so therefore the position vector of particle P after 2 seconds is 4i plus 12j. Alright, so for particle Q, I'm going to have the initial velocity being equal to 4i minus 8j meters per second. And then the acceleration of that particle Q is I plus j meters per second squared. And then now, to find that position vector at any time t, I'll have rq2 being equal to rq0 plus sq. Now as you can see, since it also starts at the origin, I'll have 0i plus 0j plus, now its initial velocity, now where there is sq, I know it's ut plus I have at squared, so I have u as 4i minus 8j times t, which is the 2 seconds given, plus I have times a, which is this, times 2 squared, which is the time taken. So when I calculate those, I have this 2 into 4i minus 8j plus 2 into I plus j, which I have 8i minus 16j plus 2i plus 2j, of which the answer shall be 10i minus 14j. So therefore the position vector of particle Q after 2 seconds is 10i minus 14j. So in part 2, we're being told to find the time at which the velocities of the two particles are perpendicular to each other. So what we should know is that when the velocities of the particles are perpendicular, it means that Vp times Vq shall actually be equal to 0. So let's look at particle P and let's find their values of Vp. So in that Up is 2i plus 6j meters per second, Ap is 0 meters per second squared. So Vp is Up plus Apt. So Vp shall actually be equal to 2i plus 6j plus 0t, because we know that Ap is 0. So multiply that way and we'll have Vp being equal to 2i plus 6j meters per second. So now we know the value of Vp. Now for particle Q, we have Uq being equal to 4i minus 8j meters per second and Ap being equal to I plus j meters per second squared. Alright, so from its first equation of motion, I have Vq being equal to Uq plus Aqt, of which I have 4i minus 8j plus I plus jt. So when velocities are perpendicular, we remember that this velocity Vp times Vq shall actually be equal to 0. So this is what I have. So I'm going to put in those values. I'm going to plug them. So where I have Vp, I'm going to have 2 and 6. And then where there is Vq, I'm going to plug in the values as you can see right there. But now I've placed them in column form. So now I'm going to multiply them in. So multiplying these t's inside, I'll have 2 times 4 plus 6 times this negative 8 plus 2 times t plus 6 times t being equal to 0. The next I'll have it as 8 minus 48 plus 2t plus 6t being equal to 0, which is the same as negative 40 plus 80 is equal to 0. So 8t shall be equal to 40, of which t shall now be equal to 5 seconds. So therefore the time at which the velocities are perpendicular to each other is 5 seconds. Alright, so in the last question, we're being told to find the time at which the point R, so R is a point with position vector 17i plus 12j, lies on the line joining the positions of the particles P and Q. Alright, so now we're going to draw a line, which is the line PQ, and then we're going to place the position R. So R is the position in between them, and R lies at 17i plus 12j. So now we can see that if R lies on PQ, then PQ shall actually be equal to HRQ, as you can see right there. So it depends, so we have a constant right there, of which H is a constant. So now we can state this side right here. So PQ shall actually be equal to the position vector at Q minus the position vector at P. And then for RQ, which is what we have here, we shall have RQ being equal to the position vector at Q minus OR, which is the position vector right here, and we don't know what that is. So now, first of all, we're going to first find what PQ represents. Alright, so first, we're going to first find what RQT is, and then we're going to find what RPT is. So you can remember that RQT shall be equal to RQ0 plus SQ. Now we know the initial position vector, it began from the origin, so we'll have 0i plus 0j, and then SQ is the same as the second equation of motion, which is ut plus a half at squared. So where they at point Q, as you can see right there, this is what I'll have. I'll have it as 4I minus 8j as ut plus I have times, now the acceleration is I plus j t squared. So this is what I end up having after solving. And then I can actually now open brackets. So multiply this t inside and this is what I'll have. Then also multiply this I have inside. So the point is I want to combine the I values with the j values. So this is what I'll have. I'll have it as 4it plus it squared over 2 plus jt squared minus, jt squared over 2 minus 8j t. So I have rqt being equal to this. So now I'm going to put in brackets where all the values of I are grouped together and those with j are grouped together. So I have rqt being equal to that. So now next I have to find what rpt is. So rpt shall actually be equal to rp0 plus sp, which shall be this 0i plus 0j plus 2i plus 6jt plus a half times 0 times t squared. So remember at position p that it was moving at constant speed from the origin. So we have its acceleration as 0. So rpt shall be equal to 2i plus 6j_t. Alright, so next therefore we now have pq being equal to that. So pq is equal to this minus that, of which I can now open brackets and solve. So now when I open brackets and solve, this is what I'll end up having. I'll have 4it plus it squared over 2 plus jt squared over 2 minus 8jt minus 2it minus 6jt. Alright, so solving this, I'll have 4it minus 2it will give me 2it. Then 8jt minus this 6jt shall give me negative 14jt. Now then let the I values with I be together and those with j be together. So pq shall therefore be equal to 2t plus t squared over 2i plus t squared over 2 minus 14t j, as you can see right there. So now next we're going to find rq. So for rq we shall have it as rqt minus o r, which is the same as this. So now the position vector at the point r is given as 17i plus 25j, and then at rqt we know that we had actually found it initially as 4it plus it squared over 2 plus jt squared over 2 minus 8j t. So working this out, this is what we end up having. So open these brackets up, combine those values that actually have j together and those that have I together, and this is what we'll have, of which we'll have it as 4t plus t squared over 2 minus 17i plus t squared over 2 minus 8t minus 25j. Alright, so from pq is equal to hrq, this is what we end up having when we equate the two sides. So next step, I'm going to multiply the h inside, and then this is what I'll have. So the h multiplies this and I'll have it this way, and the h also multiplies this value right there, and this is what I have. So the next step is I'm going to compare the values of the sides that have I, and this I'll also compare the sides of the values that have j. So from I is equal to, from I, therefore from I I'll have this. I'll have 2t plus t squared over 2i being equal to h into 4t plus t squared over 2 minus 17i. So I can see that the i's cancel and I'll be left with 2t plus t squared over 2 being equal to h into 4t plus t squared over 2 minus 17. That shall be equation 1. Then from j I'll have t squared over 2 minus 14t j minus h t squared over 2 minus 8t minus 25j. And then the j's cancel and I'll have t squared over 2 minus 14t being equal to h into bracket t squared over 2 minus 8t minus 25, and that shall be equation 2. So now I can divide equation 1 by equation 2 and then I'll eliminate the h value. So when I do that, this is what I end up having. So the h values cancel and this is what I'm left with. So the next step is to cross multiply. So when I cross multiply, this is what I end up having. So this is a little bit bulky to work with, but it is actually doable. Alright, so now I can see 14t over 2 shall actually give me a 2, as you can see right there. Then this 40 squared over 2 shall give me 2t squared, as you can see right there. So next step is I can actually see that some values cancel, but before we do that, I can actually see that some values can be combined together. So those that actually have t can actually be combined together. So now when I add this to this, I'll actually have 57t over 2. So on this other side, when I add this to the, when I get this minus this, I'll have 129t over 2, as you can see right there. So next thing, as I can see, is this and this will cancel. And then I can actually see that I can actually group this 3t squared with this negative 5t squared. So if I bring this towards this side, I'll have 2t squared. And then if I bring this towards this side, negative 50 minus 238 shall give me negative 288, as you can see right there. Then I can also see that if I bring this to this side and I add it to this 57t over 2, I'll have 72t over 2. And then I'll have a 0 on the right hand side. So next, 72 over 2 will give me 36. So I have 2t squared plus 36t minus 288 being equal to 0. So divide all sides by 2 and I have t squared plus 18t minus 144 being equal to 0, of which if I solve this quadratically, I have t as either being equal to 6 or t being equal to negative 24. But since time cannot be a negative, t shall actually be equal to 6 seconds. Therefore, the time at which the point r with position vector 17i plus 25j lies on the line joining the positions of the particles p and q is 6 seconds. Alright, so next I have an exercise for you. These are numbers you can try out and then compare your answer to the answer that I actually have there in the brown color to make sure you're actually on the right track. So practicing this out will actually make you perfect your knowledge of this section. So pause the video, copy the questions and try them out. So the questions continue, and this is the next one. This is the next one. So in total, there are actually 7 questions. So try this out, compare your answers to what I have there, and then perfect your knowledge. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. I hope the numbers were sufficient for you. If this video was of help to you, feel free to give the video a like, a thumbs up, and then feel free to share the video with all those that you can and help them out if the video really helped you. And then you can leave a comment down in the comment section for me and I'll get time to reply to you. Thank you so much for watching. I'll see you in the next video.